Fisher Process Industries. Today we're going to talk about magnetic drive pumps and the things that make them perform and have long lives in service. Magnetic drive pumps are different than sealed pumps. First difference is solids handling. On a magnetic drive pump, the entire liquid is circulated inside the can and of course the front casing, and we have close running clearances between the magnet assembly and the can. You can put streams through the pump that have limited solids in them, and we do offer in this particular case a screening device to catch oversized particles, but these are not slurry pumps, and solids is a real limitation for proper operation of the pump. Another thing that's concerning is dry running, and again, because the liquid circulating through the pump forms cooling and lubrication for the wetted bearings and for the magnetic drive, that liquid is required to keep the pump from overheating and also from having the bearings running dry. We do offer devices that could help with checking for dry run. One is a power monitor that looks at the motor load, and when the motor load drops off dramatically, that means most likely the pump is running dry and it should be turned off within a few seconds. We do also offer optional temperature sensors, RTDs and thermocouples, that sense the skin temperature right in the magnetic drive itself, typically at the can, where a temperature rise means the cooling has stopped. You're still putting heat in for the magnetic drive because the motor is still spinning, but the cooling has stopped. And when that happens, you need to stop the pump to protect it. These pumps also need to be flooded at all times, and just opening valves and hoping it's flooded on a startup for the first time is probably inadequate. You need to make sure and have a place to drain and ensure the pump totally is flooded and the air is out of it before you start it up. The next indication of a pump that's not flooded is watching the discharge gauge when the pump starts. If the pump comes up and holds a steady pressure, the pressure calculated from the pump curve and the specific gravity, you're fine. If it comes up and drops off or fluctuates, the pump is not totally flooded. You need to shut the pump off, give it a few seconds or maybe a minute, close the discharge valve partially, maybe 25 or 30%, and start the pump up again. If you get the same problem where the gauge drops off or is not steady, stop it again and go through the same procedure until it comes up and holds the rock steady value you're looking for. Running the pump partially flooded will do damage to it just as almost as quickly as running dry will. These pumps also, like any centrifugal pump, have to have the rotation checked, which is usually best done by removing the spacer element and checking the motor rotation for the direction marked on the pump itself, and then putting the coupling element back in before you start the pump. Obviously, the pump curve should be consulted to see that you're operating at the right head, and if you have flow indication, flow meters, etc., looking for the proper flow. You want the pump to be operating on the curve at all times. Obviously, if you have noisy operation that makes a gravel-like noise, you could possibly be having a pump that's cavitating. But these pumps have to be flooded and have to be operated within their limits, or you'll have damage inside. We appreciate your attention today, and feel free to contact Fisher Process Industries if you have any questions.